Mm. And welcome to this new series where we will be looking uh, for quantum algorithms under the series of quantum computing. What we have seen so far under quantum computing are the basics, the quantum mechanics, and the quantum algebra. Now, all those comes together in the actual implementation which we call as algorithms, and they are the driving force, so to say, behind the implementation of quantum mechanical concepts. So there are some must-known algorithms that you should know for implementation of a business case. Because all these algorithms tells you something about the speed up, how the speed up is achieved, what and what shouldn't be done, basically, to have that speed up. Some of the known algorithms that we're gonna look into in this series to begin with is the DOSH algorithm, which is a single bit Boolean function, Joshua algorithm, which is a multiple bit Boolean function, and we will see what are the differences and how the implementation works. But before we get into the actual building up or the constituents of algorithm, we would like to understand something about oracles, the concept behind how the algorithm is formulated, because you do not have to understand everything in the algorithm or how it has been built and how it functions internally. Now that is where precisely the oracles comes into picture. So what's an oracle? Uh, let's say that you have an input and output. You have input number as 3 and it gives you an output of 9. Now, without getting into the too much details of how the input got converted into output, if you just simply uh, look at the logic, you may find that it could be that the function in between converting input to output is a square function. So if you square 3, you get 9. It could also be a multiplication function. For example, 3 into 3 is also 9. And it could also be a combination of multiple plus a summation function. For example, 2x plus 3 would also give you 9. So there are many functions which will give you a particular output from a given input. And what we are concerned about is the input-output behavior, not the internal implementation. So it doesn't matter if it is coming from a square function or a multiply function or a combination of multiply and a summation function. We are concerned about how the input gets translated to an output. An oracle is precisely that function which satisfy your need of translating input to output without revealing which function is used and what the function is actually doing. So in this case, you pass 3 to an oracle represented at O of x, and you get 9. We can extend this implementation to a bit string representation. So an integer 3 in a bit string can be represented as 1, 1. An integer 9 in the bit string can be represented as 1, 0 and 0, 1. And since we start reading it from the right hand side as the uh, template, that's why x0 is on the right side and x1, and that's how the number is being wrote. Now you can map this through an oracle where x0, x1 is mapped to y0 up to y3. Also that the indexation is starting from 0, so the 4-bit start from 0 takes you up to index 3, so that's y0 to y3. And you can then have a different oracle maps which will actually map this input to output in precisely the same manner, just that uh, you do not have to worry about the implementation of it. Could also be a Boolean function, which helps you do this kind of transition. For example, you can have a 2-bit input which can give you a 1-bit output. And what this Boolean functions does is basically mapping of that input to output. And that implementation again can be done through various Boolean functions that the basic Boolean function that we are probably aware of, like AND, NOT gate, NAND gate, and NOT OR gate. If you take 0, 0, if you apply the AND gate, it will give you 0. If you take 0, 1, apply the AND gate, you will still get 0. If you get 1, 0, if you apply the AND gate, the idea should be should be 0. However, since this is an implementation of XOR, that's why you will see that as long as the first bit is 1, the second bit, if it's 0, get flipped. If it is 1, it remains 1. And there are many circuits, as I said, which can help you with this implementation. So in a nutshell, the concept of Oracle is to hide the implementation. You do not worry about what's inside the black box. You only care about how the input getting mapped to the output. So this is important concept to keep, and this is something we will extend further in the next lectures, but the basics of Oracle is very important to get into your thoughts once we start looking into more difficult algorithms, which are which will definitely be more complex than the simple implementation of Oracle. So I'll stop here. Thanks for listening, and I hope to see you in the next session.